For adding and subtracting rational expressions, we want to use the ideas that we learned with regular fractions to simplify rational expressions. So let's talk about common denominators. When we're looking for common denominators, back in the day when we added fractions without a calculator, we made sure our denominators were the same, and then we added the top and kept the bottom the same. So I look at the bottom of my fraction or my denominator, make sure they're the same. I keep the denominator and I add, or whatever the sign is in here, to the numerator. If my denominators were not the same, I had to look at the denominators and build them up so that they were the same. So I know that this denominator is 2 times 7. This denominator is 7. I need a 2 here, so I need to multiply by 2, and now they will be the same. But I also have to do that to the top, so I'm multiplying by 1. All right, so this denominator is okay. I'm going to leave it, but the first one I have to change. So 2 times 1 is 2 over 14 minus 5 over 14. And I can change this to plus and negative if I want to, and there's a reason for that later. Obviously, you don't have to. So negative 3 over 14 would be my answer. So if my denominators are the same, keep the denominator, add or subtract the numerator. If they're different, then we have to build them up so they are the same, and then we can go back to the original. All right, so let's check out this one. So when my denominators are the same, I'm going to keep the denominator. So I look at this, my denominators are the same, so I will keep that denominator, and then I'm going to add the numerator. So 10x minus 5 plus 8 minus 4x. That's all on the top. Let's make that 4x. There we go. All right, so I'm going to keep my denominator, and I'm going to clean up the numerator. So on the numerator, I have some x's with this, and then I also have just some numbers without x's. So I have 10x and a negative 4x, that's 6x. And I have a negative 5 and a positive 8, and that's 3. All right, my last thing is to simplify to see if I can reduce with the bottom. If you look at it and you're like, no, I can't reduce, then that's fine. Okay, but you cannot cancel out the 3's here. Remember, the addition sign links these factors together. So it links the 6x and the 3 and the 2x and the 3. So you cannot reduce top to bottom until I factor something out. So I could take out a 3, but that leaves me 2x plus 1, and that does not match my factor on the bottom. So I can't reduce. All right, but I can kick out domain issues. And to find domain issues, I set the bottom equal to 0 and solve for x. So subtract 3 from both sides, divide by 2. That's my 2 steps to solve. And so x can't be negative 3 over 2. So all real numbers, x can't be negative 3 over 2. We'll need that in the next section. All right, when the denominators are different, I find the common denominator and build new fractions. So the first thing I do is factor if it's not factored. So the last one that I did, it was already factored. There was only one factor in the bottom. I really didn't have to do anything. This one, I need to see what I'm dealing with. So on the bottom of the first fraction, I have x minus 2, x plus 2. And in the bottom of the second fraction, I want numbers that multiply to be 6, add to be negative 5, which is x minus 2, x minus 3 over 2. All right, so least common multiple. I'm looking at what's the same, so I want one of those. And then I want anything that's not the same. So I have an x plus 2 that's not the same and an x minus 3. That's my least common multiple. So I write down one time anything that repeats, that was my x minus 2, and then anything that doesn't repeat, I write that down. That's my least common multiple. So that means that's my new denominator for both of these. All right, so there's my new denominator. Now I go back to this and I see what's missing. I have an x minus 2. I have an x plus 2. I'm missing an x plus 3. So I put that on the top and the bottom because that's like multiplying by 1. And now I'm going to build my new fraction. So I already have the bottom built. So the top is x minus 3, x plus 6. In the bottom, can you tell what's missing? Yep, an x plus 2. So I put that top and bottom because that's multiplying by 1. So now I have 2 times x plus 2. All right, now I'm going to clean up. So I'm not going to multiply the bottom out. Okay, I'm going to leave the bottom, but I am going to multiply the top out. And I'm only going to write the denominator one time, mainly because I don't want to write it more than one time, honestly. All right, so x minus 2, x plus 2, x minus 3. That's my new denominator. So I'm going to multiply the top out, and I'm just going to put it up here. So that would be x squared plus 3x minus 18. And I got the 3x because it's 6x minus 3x. That gives me my middle number. And then multiplying this out would be 2x plus 4. If you need to multiply these out on the side, then do it. All right, so I have x squared plus 3x minus 18 plus, if this had been subtraction, I would have put the negative over here on the 2 and changed this to addition. Plus 2x plus 4, and then combine like terms. So I have x squared plus 5x minus 14 over x minus 2x plus 2x minus 3. Now I'm going to go ahead and factor the top and hope that something drops out. I want numbers that multiply to be negative 14, add to be 5. That would be 7 and negative 2. So x plus 7, x minus 2 over x minus 2, x plus 2, x minus 3. And I can get rid of the x minus 2. So I have x plus 7. I don't need parentheses because there's only one. I do on the bottom. X plus 2, and then x minus 3. All right, so that's my final answer. My domain is all real numbers except x can't be. And let's go back up here where we built our fraction. We'll use our least common multiple. X can't be 2, negative 2, or 3. Put them in order if you want, negative 2, 2, and 3. All right, see you guys soon.